Let me just look here. There are special units to thermal pastes, to measure, how efficient they are. Let's see, well, Arctic Silver 5. That's exactly what we are looking at. The Arctic Silver 5, the 5, refers to the efficiency. Okay, it usually goes like this. I'm assuming it is 5 degrees C rise, per watt under certain test conditions. Okay, this is how you measure, the efficiency of heat sink. You measure it by how much temperature rise are we talking about per power dissipation unit. The lower the number, the better, because it means you can dissipate more power without rising the temperature as much. Is that okay? I mean, sort of? Okay. But the bottom line, if you don't care about the physics of this whole thing, but the bottom line is, using a better thermal paste, even if it's more costly, is worth the money, because your processor is what, $200 or so, if you get a higher end type, and the time to have to disassemble the whole thing, do it all over again, buy another processor, is a lot more than what you have to pay for a better thermal paste. The white stuff that comes with the processor, either from Intel or AMD, that stuff is not good. I mean, it's sufficient, but it's not good. This is much better.
So when you buy a new one, is that something you should do when you first get it? Is replace the thermal paste?
Yeah, I never use the included thermal paste. I always, just buy additional thermal paste. So at home, I have these little packets of white, thermal grease that is just not even open yet, because I don't even bother with that.
How often do you use it?
Only once. If you do it right, you only have to do it once, because the thermal paste does not evaporate. It does not, dissipate over time, or at least not noticeably over, say, 5 or to 10 years of time. Yep.
How would you dispose of those packets? I mean, the cheap ones.
The cheap ones,
Yeah.
I keep I keep them around,
Just in case. But I mean, if you were to, because they're probably different, can you just...
They have lithium on it. They have lithium compound on it. I'm not sure what is the proper way to dispose of those. Yeah, that's a good question, because I'm pretty sure at larger quantities they can be toxic. So it's a good idea to think about how to dispose of it, but I don't know exactly how. Okay. Any questions about thermal paste? No questions? Have we talked about CPU coolers? No? Well, that's a good thing to talk about too, since we are already on this very topic. How many people use the built-in or the included CPU coolers that comes with Intel or AMD processors? Is that working out fine for you?
It was fine for me. Yeah, a lot of extra fans, so I mean.
Oh, this is a good time to show you that video clip. CPU explode.
That's no good.
That's always a good thing to look at,
Yeah.
This is what I'm going to present you an X-ray.
Okay, let me change it to the main speaker. For some reason, the system always used the speaker inside on the motherboard, which is not the best speaker. And okay, we'll try that.
Let's see it. As you can see, there is a CPU Z of AMD Dual Spitfire 3818 MHz. Look at the extreme overclocking.
All right, moving on.
Fun fader. Oh, can you change it for me? Another one now. Yes.
Come on, just show me the explosion. Oh, okay. I skipped too much.
must change it for me, huh?
Okay, so what they're doing now is they're running a benchmark program. Benchmark programs are designed to exercise the CPU as much as they can. In other words, your processor will run really hot, or it will run at its maximum temperature when you run these benchmark programs. And what they have done is they have loosened all the screws on the CPU cooler itself, so they can just lift the whole thing, in a short amount of time. And this is what happens.
Okay.
Wow. And this is slow motion. Well, but the interesting part is yet to come. And for those of you who have seen it.
AMD has exploded. What happened?
Yeah, that's universal language there. It blew a hole on the table. Yes. The chip was physically broken up into these pieces.
The processor has literally exploded the socket. You make sure of me. Oh. This is the microphone. Oh yeah. Oh, what an extreme. Too much. Too extreme.
So there you have it. Now, how much time did it take, before it blew up? Seconds? Okay, I just want to measure how much time it took. Because I want to...
Yes. You must change it for me, huh? Okay.
2 seconds. Okay, so you can measure the amount of energy contained in that small explosion. 2 seconds, times whatever the power consumption of the processor is using at that time. Now this is back in what? This is an older video clip, so it has been around for a while, 5 years ago. So I would assume that processor is using 160 watts or so, because technology was not really as good as today. So 160 watts times 2 seconds adds up to about 300 joules of energy. That's 1 J or 1 joules is a unit of energy. The question is not how much energy we are talking about, is how quickly it is dissipated. Because that 300 joules of energy was dissipated in a small explosion. And that's what a small explosion can do. It basically became a firecracker. The processor became a firecracker.
Pretty heavy duty one too.
Well, yeah, if you can blow a hole on a wooden table like that, I can see that it can be dangerous on an airplane. So now they have to ban these processors on an airplane.
There goes computers.
There goes computers are actually extremely dangerous if you think about it. You just have to short out the terminals of the battery. That's already a small explosive right there. Because most lithium-ion batteries will explode when they are shorted. Okay. So what happened here is, if you look at a processor, it has a substrate material, basically a backing material. The processor chip is actually here. It is really small, compared to the entire package. And then on top of that, they have some more stuff on it. This is basically the heat sink, that you can see, which is a lot bigger than the die itself. So this is entirely enclosed inside. And normally the heat will go through this material, go to the CPU fan, and then get dissipated. When the CPU fan when the CPU cooler is not there anymore, then all this heat is just radiating out. But you can only radiate so much when you have a tiny surface area about that big. In other words, the temperature inside will basically rise or increase very, very rapidly. And as a result, what happens is this stuff here will basically get molten and then turn into a gaseous state. When the gas pressure is high enough, it will just break both on the top and also on the bottom and became a small explosion. And that's what you were seeing, the small explosion is because all this stuff here, all the silicon inside, turned into a gaseous state, and the gas had enough air pressure to push out and cause the explosion. Yep.
So it was a pressure explosion, not a gaseous explosion.
It is the gases from from turning all this stuff inside the chip into gases.
So the chemical inside of it is actually an explosive material, or the
No, they're not
it's just the
explosive.
pressure?
It's just the pressure. There's no oxidizing agent here, so this is not explosive as we know it, because there's no combustion. It's all because of just heat and confined area until the material cannot stand the pressure anymore.
Just like overfilling a balloon, so to speak.
Exactly. Yep. There was a hand somewhere. Yep.
Was this intended to happen? Or was
I don't think they expected it to explode, and blow a hole on the table itself. I think they were expecting it to smoke, maybe. Most semiconductor will basically, smoke, when they die. Most semiconductor would not explode. They will crack the case to release, the air pressure, but it won't cause like a big explosion. It will just kind of crack, and you can hear the hiss. We call it letting the genie out of the chip. But in this case, it's a small explosion, which is a lot more violent than most other chips.
Was this on with energy going into this, or was it turned off?
It was on.
It was on.
Yeah,
So
it was on. Yep. hmm Now, what if your fan dies? What if your CPU fan on the CPU cooler dies? Which will happen. Mechanical devices will die at some point. Do you think you will hear an explosion inside the case of your computer?
maybe not melt necessarily.
Yep.
Normally, your computer will start malfunctioning in that case, but it still had the heat sink on it.
Yep. If it still has a heat sink on, the temperature will still increase, but not nearly as quickly as in this case. Most CPU these days have also an auto protection feature. When its own temperature is up to a certain extent, it will just cut power to itself. It will shut itself down. And as a result, it will just prevent itself from exploding. It can still cause permanent damage, okay? But it won't cause an explosion. Yep.
How can you tell if you have permanent damage on your CPU?
You can't, it's just a reliability thing. If your computer otherwise is okay, but it keeps resetting itself once in a while, it could be your processor getting some sort of internal damage.
Well, because a bunch of dust had gotten in my heatsink,
Uh-huh.
and my computer, when I would try to do stuff, started like almost lagging. Not like a game, but just
Okay, if it is lagging, it is not dead. Okay, if your processor is just kind of lagging, doing things a lot slower than it used to, it's basically software or semi-hardware compensating for it. In other words, your processor, which normally operates at, let's say, 2.4 gigahertz, will basically sense its own temperature and say, oh, I'm running kind of really hot here. I should not be operating at 2.4 gigahertz anymore. It will clock itself down back to maybe 1.2 gigahertz or even lower. So as a result, what you see is the computer is getting really, really slow, but it's really the processor and plus the software component together trying to preserve itself and say, okay, I should not be operating as quickly because I cannot dissipate all the heat anymore.
Okay, and then I cleaned out the dust and it stopped. So you don't think there might have been that much damage to the
I don't think there's any damage. It's really just the software. This is called throttling. Most modern processors can do throttling, and it is more common with laptop computers to conserve battery power. But with a desktop computer, the processor is capable of throttling as well. And in this case, it's basically a thermal triggered throttling to say that I'm running too hot. I need to slow down so I don't kill myself. And in some cases, if you have a big enough heat sink, you can even go without a fan intentionally. In other words, just because there's airflow inside the case and you have enough thin surface area, a CPU can be passively cooled in some cases. I cannot say in all cases. It depends on the type of CPU, depends on the speed you're running it at. It also depends on the airflow and the ambient temperature. But in some cases, if you have a big enough CPU cooler, you can even